Hello, ladies and gentlemen, and welcome to our webinar analyzing CMYK content. So the next 10 to 15 minutes we will talk about how to analyze incoming untagged CMYK image, which is unfortunately often the case. So print service providers often get untagged CMYK images or sometimes wrongly tagged CMYK pixel raster images. So hence it is not known which separation was actually used to create that information. And this lack of information can lead to significant printing problems like different separations on a printing form or too much ink load, and so problems in post-printing and printing, of course. And print service therefore have to make an educated guess to see what might the creator have used for a printing profile to separate the image content. And here you see if the image, the tone value sum or the total ink coverage, total area coverage is too high. Especially here you might see that the separations, the image data can't really be used in that printing process. For instance, newspaper printing, this is much too high. This can also be the case if something was separated correctly, but then CMYK retouching took place. Okay, but let's see how we try to solve it. The principal idea is to use the consistency of ICC tables. So, and you Photoshop to manually apply it. An ICC profile looks like this here. If you open ISO-coded, for instance, you see many tags here, the header tag and many more. The most important are the color transformations, going from A to B, from device to PCS, and back from PCS B to A to device. So in this case, from LAB to CMYK, and here the three numbers means perceptual, relative colorimetric, and saturation. Absolute colorimetric is just a transformation going from here with the white point, which is encoded here. Okay, but today we don't speak about ICC anatomy, we talk about how to apply it. And the basic approach is the consistency among them. So you have a CMYK data, you have an estimated ICC profile, you convert to LAB, convert back, you separate to CMYK, and you compare basically both. And the closer those are, the better, or the most likely the estimated profile was used for separating. Okay, let's see it in practice, how it works. Let's start with a typical image content, and let's take this picture here. This is a PDFX creation, which is a Fogra certification where we test if content creators can reliably create PDFX files. So just as an information, if you would like to know more about, you go to fogra.org, Fogra cert, change here to English, and then see how many Fogra cert we have. In this case, we talk about prepress, data handling, and we talk about PDFX creation, and we have another one, PDFX output. So if you would like to learn more about, just go here and see how this works. But here we get this data, and now we check, okay, is this PDFX? Of course, it says here, output ident, ISO-coded V2, okay. Let's verify, okay, it's positive, so it might be positive. But again, this is just an kind of a label. The output intent you quite don't know. Actually, is this really separated with that image? And we will show that in a few minutes. So in order to find out whether this pixel image here has been really separated with ISO-coded V2 300, we open it in Photoshop. Edit document, edit image, and you get here untagged CMYK image. So you see already here the channels, and the experts might know already by seeing here the films, so to speak, the contour films. what happens under the hood, but we make it here objectively. So that means we assign our profile here and we duplicate the image. So we have now two identical CMYK images, and here we do what we said. So we convert to profile. Where do I come from? Where do I want to go? Which rendering into use? Okay. Now I have an LAB image. You see here LAB. You see here LAB, but we go directly back, separate that image from LAB to either coded V2 300, and we get now a CMYK image back here. And what we now do is to compare the separations, the planes by planes, cyan with cyan, magenta with magenta. And for this we can do here simply calculations, and we compare the first one with the copy. We subtract channel by channel. So you see, let's say cyan channel minus cyan, so subtract. And if you normally subtract, you get this, but then you're not so sensitive to the differences. So we add 128 to the differences so that we can see the differences much more clearer and save the results, the differences of the channels, or for yellow, for instance, in a new image. So we have a third image here. And in case this were perfectly identical, the histogram here, the histogram would be a line and the standard deviation would be 0. No variation at all. But here you see very tiny separations and very tiny tolerances. So the likelihood is extremely high. The tolerance we propose from Fogra based off our research done where we developed this method is about 5 to 6 units here, tone values, standard deviation, to get a good estimation that this profile was actually used. Why is it so important? Let me tell you. We have seen that this is just a label, so I tell you something which you shouldn't do, but which is often done in practice. So you have this ad, for instance, and you say, okay, I have some budget left over. Let me do a print ad in a newspaper. So we just save this ad, this PDF, for let's say here PSD News, and we save it as an PDFX file, X1A E426. Okay, let's do it. And you might already guess what's happened. Under the hood, it converts now the file to E426. But so let's close it. Let's open it again to be on the safe side. So that means here, let's see. Okay, E426 is a newspaper. Seems to be a very good ad for newspaper. Let's verify. It's verified. Oh, very good. But what you see already is, if you don't believe me, that here so let me just open my output preview. Here we go. If you see the total area coverage, you see already, a lot of tone values are too high. And this causes problems, especially in newspaper printing, where 200 or 240 is a limit. And if you still don't believe me, we can go back to Photoshop, delete this, and open the image again. At content, edit image. No, edit image, open it, and so you can compare it here directly, and now you have a virtual identical copy. But we can also say we close this original one. We have now the ones open from our E426 PDF, and we can apply our method and see whether it works here, not only to show us the correct profiles, but also to show us mismatches. So we apply now E426. You see what happens here. So we apply it, and then we duplicate, and then we do what we said before, we convert to profile, IFA to LAB, in this case relative colorimetric, and we convert back. And now we make a calculation. Yes, this one with this one, and you see already what happens in the cyan channel and the magenta channel, a lot of differences. And if you see this here, now the result is stored in an alpha channel, but you see the standard deviation is much higher. And of course, you can also do this for perceptual rendering intents, and you will see the same. And with that, you can see to test is the tagged image really separated with that tagged profile or not. And most important, if you get untagged data, how can you estimate which profile has been used? And if you have many time, you can do this procedure for many profiles. And this actually was the concept for accepted or built on from Color Logic. And they transferred the concept to many typical profiles. So in the so-called DocBees color profile tagger, you can add a PDF and you check for different profiles, and then it gives you a percentage how likely it is that the picture in the PDF was actually separated with that profile in that list, in that pool of profiles. And even better, it can give you a PDF which tags this kind of profiles in the so you will get a PDF with tagged profiles which are very likely to be the one that your creator has used. Of course, and this with this I will finish, it is better to negotiate and to communicate the printing condition and ask the print or the data delivery party to deliver PDFX compliant data and use PDFX information as we provided on our webpage too. So let me finally show you where you can find more information about Fogra printing, PSD, downloads, and you see a lot of information here. And for instance, the PDFX ready pre-flight profiles as of Acrobat 9 and much more information here to create content correctly, to pre-flight content correctly. And last but not least, you also find it in the PSD Handbook 2014 in Chapter 3. With that, I would like to finish. Thanks for your attention and talk to you later. Bye bye.